Hi there. I'm Justin Vaughan-Brown in Product Marketing at AppDynamics. Delighted to welcome you all here today for the session. Today, we're very, very pleased to have Hunter Mott from Jack Henry & Associates. Jack Henry are a provider of critical technology infrastructure to financial institutions. And Hunter's got a great, great story to share today. He's the main act, so I'd like to hand over to him and welcome you all. Thanks very much.
Thank you, Justin. I don't know whether I am happy that I get to follow up the session earlier, or if that means I have more pressure because I have to try and, show up those guys, which I probably won't do, so just going to throw that out there. I'm kind of going to go through the presentation here. I'm totally open for questions and all that kind of stuff. I'd love interaction, so as I kind of step through stuff here, feel free to ask any questions you guys have throughout the presentation. Legal disclaimer, I have to put this up there. That's that. So a little bit about Jack Henry & Associates. Like Justin mentioned, we are a financial services technology company. So we provide basically all of the technology pieces that banks and credit unions need to operate. That's everything from the systems that sit in the bank and process the accounts, hold all the account information, process your transactions, that kind of thing, to online banking, online bill pay, e-statements, pretty much everything that a bank would need technology for. We have some banks that are our clients that basically we are the entire bank. They'll have a dozen people. We do all of their processing, all of that stuff. It's really a pretty cool deal. We have about 10,500 customers around the United States, as well as a few international customers. We're really largely a U.S.-based business, so pretty much everybody that we deal with is here in the U.S. About $1.35 billion in revenue for 2016, 6,000 people throughout the country. We have about 35 offices spread all around the whole country. Our headquarters is down in a little town in Missouri called Monette, Missouri, which is really pretty cool. It helps, I think, give the company a little bit more of a small town, small company feel that you don't get in a lot of companies with 6,000 people. The group I work for specifically is Internet Solutions. So kind of as the name says, we do basically everything that you can think of for the internet-facing side of a bank. Online banking is really kind of our biggest thing. Mobile banking, online bill pay, e-statement providing, that kind of thing. It's a really pretty cool industry to be a part of. It's been changing a lot. I'm sure a lot of you guys kind of experienced the same thing. Anything internet-based has just been changing so quickly the last few years. It's really a pretty cool deal. We host online banking for about 1,400 banks and credit unions around the country. So wherever you guys are, there's a decent chance that we have probably somebody in your community that we host the online banking systems for. We have about 67 million logins a month, which is, I think, a pretty cool number. It's a pretty significant amount of users that rely on our systems day in, day out, that kind of thing, for everything from commercial banking to personal banking. They get on to kind of look at all that kind of stuff. The second to the bottom bullet point there is kind of one of my favorite numbers. Because of the massive customization that you can do within our app and the number of banks that we have, the possibilities for how a bank can be configured is pretty much endless. 1.8 by 10 to the 311. It's a 311-digit long number worth of possible combinations that we would have to go through a regression test to really test our whole app. You guys all know that's not really possible. I'm guessing most of you have that same kind of thing in your apps where you really can't go through and know that everything's going to work just because of all the complexity there is. We run things in an active-active posture, so we have 2 data centers that we run out of simultaneously, which gives us a lot of flexibility in how we do things, but also adds some additional complexity in that we have to monitor performance out of 2 separate places independently, and they will react differently to different things. So we don't have the ability to just watch our app. We have to watch our app, but we have to watch the app in both data centers. So that adds a lot of complexity to just kind of traditional monitoring type systems. So I'm kind of going to step through. I noticed on my overview that it said I was going to step through 6 challenges. I added a 7th, so bear with me. If I go long, I'll skip one of them or something. I'm kind of going to go through basically, though, and give you guys kind of some examples of the stuff that we were looking at in our app that we weren't able to get around, that we weren't able to solve for, that was causing delays, causing problems, outages, that kind of thing, and kind of how we solved for that and how AppDynamics helped us get past those hurdles. So I'll kind of go through some of the stuff here. The number of unique configuration possibilities, I kind of touched on that last slide. 311-digit long number. To do a complete regression of that, if you said you could do a whole regression of the app every like 20 minutes, would take, I think it's something like 12,000 years. Not really a possibility when we do code releases, 2-3 times a week. Release frequency, the next one. We do a full release every 3 weeks to the app. That said, you guys I'm sure deal with this as well. A full release, you got to do bug fix releases. You have to do emergency fixes in there. We end up doing about 3 releases every week of the app. Technical debt, again, this is something that I think is really true in banking. I know that there's a lot of other businesses that deal with this as well, where systems have just been around for so long that nobody really knows what the system is doing anymore. The developers that wrote it, they're all retired. They don't care anymore. The developers that you have now may have known the people back 15, 20 years ago, but they've forgotten half the stuff already. So you end up with these systems that nobody really can define. Nobody can tell what's supposed to happen. Nobody can tell what the right solution is. So you end up chasing your tail trying to figure out why this won't work because nobody knows how it's supposed to work. Massive remote connectivity. We have the 1,400 or so financial institutions that we host. A large portion of those financial institutions host the database of record in their brick and mortar store. So we're basically a software as a service platform where we will deliver your online banking for you, but we're going to go and get the data from your database of record. So we have to deal with internet connectivity issues going to the banks, internet connectivity issues going to third-party providers. We have third-party providers that do things like check image displays, bill pay, multi-factor authentication, that kind of thing. So we have to be very cognizant of all of those remote endpoints and have to basically monitor their performance in addition to the performance of our app. Code spaghetti, this kind of goes to the technical debt again, where you have people that write code that really makes no sense. Circular code that may have made sense at one point, that got left in there for whatever reason and never cleaned up. Our application is a very, very large application. We have about 600 servers in the production environment across about 24 unique application tiers. So depending on what the application is doing, it may go one path for one part of their login transaction and another path for somebody else's login transaction. So even just to process a login, it doesn't follow the same process for every bank. And kind of the focus. Developers, their job is not to make things supportable. Their job is to make revenue-creating products. I don't always agree with that, but that's kind of the directive that they get, so they have to do their jobs. So we have to kind of be able to go in and figure out what their stuff is supposed to be doing and how to go back to them and help us, and help them help our customers. Capacity management, I know that that's something that really pretty much everybody has to deal with. The more capacity you have wasted, the more money you're wasting, the less efficient you're running. We really, before we got AppDynamics, lacked a single interface that we could go to get a good view of our capacity across all of our infrastructure. And then finally, infrastructure spaghetti. Again, as technology has evolved, as security has evolved, everybody has a different practice, and every 3 years somebody comes up with a new best practice for security. At one point you change the SQL port because you don't want everybody to know what port your SQL is listening on. How many people still change their SQL port? Nobody. Wow. That's impressive. But I think there are so many practices like that over the course of the last 15 or 20 years have changed in how we approach things like security, that you end up with firewall ACLs that nobody knew that were there. You end up with these pieces of the app that communicate to things that they hit once a month that nobody really realizes that we're relying on. But you get rid of that thing, and it goes through and purges a column out of your database. And now your whole app doesn't work anymore because it can't get to that one thing that you may not have even known it needed, really. And then kind of the external connectivity again. With our app, because of all those external endpoints that we have to connect to, we connect to some over just kind of the traditional internet. We also have a VPN, excuse me, that we manage that handles a lot of our internal connectivity stuff. So you have to be aware of which communications channels you're utilizing for that kind of stuff so that you can know where you need to go to track down those problems. So the number of unique configuration possibilities, again, we have about 400 different options that a bank can go in and change within the app to change how their app appears to their users. That has about 6 or 7 options average for each of those 400 different configuration items. So that ends up with, you can see the math there, 1.82 la-di-da-di-da to the 311th power. There is no way to get in to test that. That is something that you can test the majority of. You can unit test all you want, but your unit test isn't going to tell you how that code is going to interact with some other piece of code. We had one the other day where they had a CSS sheet that was being called to display an error message. And somebody had an error where they couldn't get to the CSS sheet. So it created this circular looping error where you just kept getting an error that it couldn't find the CSS, and it could never display the error because it could never find the CSS. And that's just one of those, that's a fairly simple one, but there are so many of those pieces of the application that nobody really knows that it gets very, very difficult to track down where the problem is occurring. So one of the things that we really found that was hugely helpful with AppDynamics, we got in, and there are pieces of the application that we found out had empty try catches, where we were throwing errors, and we'd have a catch block in there, and it would just get discarded. So we had, if you look up there, I think that's over the course of like a week, we were throwing 4 million of these errors a week, and nobody knew about it because we weren't logging it anywhere. And you can kind of see up there the huge drop in errors. That error was a DNS record lookup. So we had the application that was going 4 million times a week trying to do a DNS record lookup, timing out, doing it again 3 times. You got 21 seconds of timeout for every one of those 4 million errors. That creates a huge amount of constraint on your resources on your servers. What's that come out to be? 12 million connections, TCP connections that are stood up and torn down because it can't get what it needs to do. And your app's going to sit there and hold those connections in memory while it tries to process the transaction, but because we weren't logging that, nobody knew that we were having those problems. We went in and created a couple A records, the problems went away, and you can see that huge drop in errors there. Release frequency. This is something we're a little bit slow, I admit. Financial services is probably one of the least friendly groups to doing anything fast, other than probably manufacturing. So we do a scheduled release every 3 weeks with emergency fixes, hot fixes, all that kind of stuff, stuffed in, every other day, that kind of thing. I'm sure there's a lot of you guys that are getting into the continuous integration, continuous delivery kind of a thing, where as you get into that, you no longer have the luxury of defining what exactly is changing. You don't have the documentation. You don't have the communication as to what your ops teams need to be looking at. So we kind of had a very similar thing. As things would go out, we'd push them out. They'd have to get backed out because something would go wrong. with traditional monitoring systems, when you pull that back out, how do you go back and figure out what the problem really was? You can't go troubleshoot it because it's not there anymore. Depending on what you had for your logging, you may or may not have the right information. With AppDynamics, it sits there and it pulls all that information regardless of whether or not the developers thought to put it in there. And just kind of one of our issues led to a huge lack of confidence when we were doing a release. It was, and still occasionally is, a joke that we'll sit back there and say, you know, what's the odds that we're going to have to pull this release out? 5 to 1, 10 to 1, you know. And we'll sit there and joke about it, but that's a real problem. When you don't have confidence in your release and you're turning that on for your customers, how can you turn that on for your customers when you're not confident that it's going to work or that you're going to be able to detect the issue before they do? AppDynamics came in, and one of the features in APM is a compare releases functionality. This lets both our QA groups, our load test groups, as well as our production groups get in there and look at the comparison between how the different releases function. You can kind of see up there the call volume, the average response time, the number of errors, that kind of stuff. That will get in there, and it will give you, you know, it's not 100%, but it gives you some level of confidence that yes, your release is functioning the way the old one did. Or no, it really is way worse. We need to figure out what's going on. This gives you the data to be able to go back to the development teams, the product teams, and say, hey, what'd we do? Why'd we break this? Look, I have this data that shows that we were better 2 days ago. What do we need to do to get back to that point? And it's an extremely easy feature to get in and utilize. You can get in and you can look at release day by day. You can look at week by week. You can also use this to get in and look at how your release was performing a year ago versus now, to see if your project to improve your infrastructure really had that desired effect. So much of that stuff is a small, minute improvement that if you look week to week, you may not see any difference. But if you go in here and you look year to year, you can actually see what the effect of all those projects that you've done have actually had. Technical debt. This, I think, is very common both in development groups as well as in operations groups, and really any group that sits there and deals with the changes in technology that happen every single day. We have systems in our app that are built on C++ code from 1990, 1998 that are still sitting there running active pieces of the application. I came from Ford Motor Company when I came over to Jack Henry, and in 2008 when I started there, we got rid of their last card reader. So there's so much technical debt, and I really believe every industry that you really can't know all of the pieces and you can't stay on top of all of those changes without something to kind of help guide you and help give you that visibility. We also have struggled quite a bit with our app. We have the ability for an FI to come in and request custom code. So if they want something that the app doesn't do normally, they can come in and say, hey, we'll pay you, go develop this code to do this piece of functionality for us. We have pieces of the app that were developed to go do something for one bank that somebody then got the idea that, hey, let's start selling this to everybody. So you have this product that was designed to go do one thing for one person that, as a developer, if you're sitting there coding something with a very specific functionality in mind, you don't have to go through and load test that. You don't have to do all the performance tuning for that because it's for one person. You turn that on for 1,400 people, and the impact can become very, very significant very, very quickly. So we have a lot of that stuff where the architecture really just isn't enterprise class. And you have the problem where you don't know what all of these systems are talking to. Along with the enterprise class architecture, how do you get to the point that you have confidence in knowing when a certain piece of your infrastructure fails, how that's going to affect the functionality of your app? How many of you guys can tell me for a login transaction or something into your app what the full path for that login transaction is? I got 2 hands? That's not bad. But there are so many complexities in all of our apps, I think, that you don't always know what's going to happen if you lose a system, if you lose a piece of functionality. AppD gets in there, and with the transaction flow map, you can actually get in and look, if you have this tier fail, what all is that going to affect? What are the ripple effects going to be for that tier failing? You can get in and look at it both from a business transaction level as well as your overall infrastructure level and see what things are going to call that, what requests are going to start failing, where you're going to start getting errors. And then you can also alert on all those errors. You can also use scalability analysis. This kind of gets into the capacity management a little bit, but you can get in and AppD will very, very easily give you an analysis of your load and response time. So that one there, that one's actually CPU versus load. But you can see for this app, the CPU utilization scales very linearly. We have some apps where it's an exponential scale. So you get in there, and as we add more customers to this app, it becomes increasingly difficult for us to stay on top of it. And you can get in and you can look at, through the scalability analysis, where you really need to have your infrastructure to be able to support that functionality in your app. And there's the response time versus load. So this one you can see the CPU is very linear, and you can kind of see there the exponential response time versus load. That one is fairly flat, but we've had some where you get to, what's this, 20,000 requests up there, and it starts climbing almost vertically to the point that the app really becomes almost useless. But you can use these tools to get in and look at where you need to build your infrastructure to be able to support the functionality in the app. Remote connectivity. How many of you guys rely on third parties to provide services for your apps? Almost everybody, huge portion of them at least. We have, as I mentioned earlier, we connect to about 1,500 different remote endpoints, 50 million requests per month, I guess, to just the top 10 of those 1,500 endpoints. That's both a huge amount of taxation on our connectivity, as well as the potential for a huge impact on the app if one of those third parties slows down. We have some third-party providers where a slowdown in their systems will affect other clients that don't even have that system because of the increased load that it puts on our infrastructure. So having the ability to get in there and see where all those are, to know what they all are, and to know what the baseline for their performance is hugely helpful. Some of our apps, we have, you build your baselines for your app. How many of you know what your baseline for all of your third-party connectivity is? Until you have that, you can't go to them and say, hey, what was your problem here? Hey, how can we work together to improve your delivery? Or how can we work together to resolve this issue that started on this day for your service? It gives you the ability to go back to your third-party providers and say, hey, you broke something. Let's work together and get it fixed. And that's kind of the requests, the response times, errors for each of those remote endpoints you can get very, very easily through AppD. And with a little bit of customization, you can pull back even more data than that. You can kind of see here, this is, that's not our top 10, but you can see, the response time, the number of calls, the number of errors per minute, and you can get in and drill down for each one of those remote endpoints and get a graph really very similar to what you get for your app's functionality. It also gives you the ability to get in and see when one of those remote endpoints starts to affect your service. You can go in and you can view in the transaction flow map what all pieces of your app are relying on that service. So we have some of our third-party providers that we connect to through multiple places in our app, where you may see a slowdown in one place that's not the main provider for that functionality, But because, again, at some point somebody decided to do something off on their own, you have this strange connectivity that's going there that you didn't know was going to cause you problems until you get in there and can view that transaction flow map. This information on the remote services is hugely helpful for both providing the ability to go and troubleshoot those things, as well as the ability to go to your clients and your third-party providers and say, look, we see why this went down. You can go back to your clients. I'm guessing a lot of you guys have SLAs. Without something like this, it can be very difficult to go back to your clients and say, look, we know we were down, we know we were having a problem, but here's why. Code spaghetti, I don't know if that's really the right term, but I thought it was kind of funny. I mentioned we have pieces of our app that are running on 15-year-old code. That code, I don't believe we have the source code for anymore. We still have the guy there that wrote it, but he's a senior manager now, doesn't understand his own code anymore. I can say that because I'm a manager. And trying to go through and rewrite or redo those pieces of the code, nobody really knew what the impact would be, what that functionality was, what pieces of that code were actually still being leveraged. You have this huge, huge chunk of code, and it may be something that, as time went on, people tack stuff onto and stop using that old piece of code. So when you go to rewrite it, how much time do you want to spend rewriting code that's not being used anymore? Pulling things out of kind of that legacy model, I guess, can lead to a lot of confusion. As you're doing migrations, that kind of thing, with our 1,400 FIs, we do a lot of things in batches where we'll do, 10 financial institutions will move on to this new product, test it out, make sure it works, then slowly move everybody else over there. Without something like AppDynamics that can tell you for that user or that financial institution which path they're going down, as you do these kinds of slow migrations onto new technology, you may have somebody that calls in and says, hey, this is broken, and spend 6 hours chasing down the legacy path when they're actually going down the new path. And as I mentioned earlier, so much of development can be focused on the revenue. They're focused on putting product out there, not necessarily on making products supportable, improving products. AppDynamics really gives, for us at least, a very good way to get in there and pinpoint specific things that we can go to the developers and say, hey, here's this line of code. Can you go fix this one thing for us? We'll tell you what you need to do. Go fix it and make everybody's lives better. And that kind of gets into stack trace stuff. As I mentioned earlier, we have stuff in our app where there were empty try catches. We were throwing, this is actually, I think, one of those DNS errors that we were throwing. We were throwing these errors, and because nobody coded the app to record those errors anymore, they disappeared. So AppD goes through, and because it sees them as a .NET error, it will record them. And you can get in and you can see this level of detail for every error that you get in your app. You can go in and pull the exact methods out of here. We don't have it on this, but if you go in and you put the symbol files out there with your code, it will actually get down and will give you a line level in your code where that error occurred, which, that can be hugely helpful in some cases. It can be kind of a wash in others, but it lets you get down to where, as a fairly non-technical person, as a manager, I can get in there and I can see if we have an error on line 53 70,000 times, we probably need to go look at line 53. If we have an error on a different line every time, then we probably have a different problem on our hands. And the transaction snapshots do a really good job both of catching this level of error detail as well as giving you stuff like what your CPU utilization was on the servers, showing you the full transaction stack, where it went, all of the systems that it went through, and the response times for all of those systems. So if you see an error on one tier and look at the response time for the next tier down the stack, and it was 45-second response time, you know that while you got the error on this tier, that may not actually be where the problem lies. You probably need to go figure out why it took you 45 seconds to get a response. And there's the, forgot I had that on the slide. So you can see there, this one here, we had, that request took 1.2 minutes to go from the web server back to the app tier. We threw an error on the web server, but the problem actually resided back behind that in the response that it was getting back from the app server. Capacity management stuff. How many of you guys actively do capacity management? What kind of tools do you guys use for your capacity management stuff? SCOM, Excel, Notepad. Yeah. There's so many things as far as capacity management that you can do, and there's tools out there that'll do it, but so many people, us included, rely heavily on manual data input, partial analysis, and just generally not looking at the full picture. We spent a long time doing our capacity management based on one server in each tier. We would look at the first server in each tier because we didn't have a good way of aggregating all of that data. You try to look at CPU utilization every 5 seconds across 600 servers for a month, and you're going to have a useless amount of data. So we were narrowing it down to one server and realized at one point that this server had been showing 2% CPU utilization for like 3 months. Well, somebody had taken it off in the load balancer. So that made that data pretty much useless. AppD gives you a very, very easy way of going in and pulling that data for all of your apps, all of your tiers, that kind of thing. One of the issues that we ran into, being financial services, so much of what we do is very cyclical, very batch related. End-of-day processing for a bank or a credit union happens at the end of the day, every day. Bill payment, going and getting paychecks, that happens at the same time for pretty much everybody in the country. So we have huge changes in our utilization based on the patterns for when people get paid and that kind of thing, which as you get in and you're looking at that stuff, again, doing it manually, looking at an Excel file, you may catch part of it, or you may see this huge spike and panic, but it's just the cyclical piece. We were able to go in and using AppD, you can go through, and AppD's APIs allow you to go in and pull all of the metrics that you can want very, very easily. So AppD records all of our CPU, it records all of our memory, it records the number of connections for everything that we have. This was actually, my boss wrote this. That's how easy it is. I told him I was going to say that before, so I'm okay. But you can see here, this is the entire API call to go through and record or pull a CPU utilization for an entire month for a server. He wrote, I think it's probably about a 200-line PowerShell script that you can go in and put in any metric that you want to pull, and it will go through and for every server and every tier, we'll pull that metric and we'll highlight anomalies for a tier. It will give you the, I think it's set at this point, I guess there's thresholds that you can put into it. So it will give you the amount of time that tier spent above your threshold for CPU utilization, above your threshold for memory utilization, that kind of thing, which lets you get in and look at the population as a whole and then very quickly and very easily highlight where you have these anomalies, where you have these things that you need to go look at. Where before, trying to sort it through Excel, you have EPO that goes off once a day. Your CPU spikes, but do you really care that your CPU spiked because of EPO at 2 in the morning? For us, not really. Our traffic's like 10% of the regular volume at 2 in the morning. So that AppD does an awesome job of both getting all that information in and making it very retrievable. At this point, we do it for our capacity management. You can also go in and put data into AppD. We're working at this point on getting in and using the APIs in AppD to allow us to flag a server when it goes offline in the load balancer. So I don't know how many of you guys have gotten in and looked at the events in AppD, but there's events tied to every server. So you can get in there and just using AppD and our F5 infrastructure, you can have the F5 send an API call to AppD that says, I'm taking this server offline now. Mark this event. So then when you're going in and you're looking at your CPU utilization, your requests per minute, that kind of thing, you see that event that can tell you what happened instead of having to dig through CRs and emails and all that stuff. Infrastructure spaghetti. As I mentioned earlier, things like changing security practices cause gaps in how we do things. Security through obscurity. Changes in operational responsibility. The group that I work for at one point had responsibility for all of the infrastructure. We had the servers, we had the communications infrastructure, we had the VM infrastructure. All of that was in my team at one point. Now all we do is manage the app. We don't have any visibility into the VM infrastructure or the firewall configurations, that kind of thing. So as those things shift, you lose the visibility as well as the expertise that you may have at one point had. And then again, external connectivity. That's a huge one for us. These things make it so that your infrastructure can be really hard to manage, especially when you have to go through a third party to do that management. We have a group in Jack Henry that's the enterprise technology group, and they manage all of the firewalls, all of the communication stuff, all of the physical and virtual server infrastructure for the company. But you have to have the right things to go to them to have them fixed because they don't know how your app is going to work. That was the map that we had at one point of how our application functioned. That is literally the best thing that we could come up with to show the communications in our app. That's useless. I mean, it's maybe theoretically better than nothing, but it's pretty useless. You can see all the tiny lines there, and as you get in, you may be able to get in and figure out what one thing is talking to, but you can't figure out the path for the full transaction. You can't really understand how the app is working based on that map. And again, AppD makes it so easy with that application flow map to give you where all your app is going. Each one of those little green dots there, has the different pieces of the app that you have defined in there. That also gives you, that previous slide, doesn't show anything for performance for any of those. Everything there looks the same. We could have a massive problem, and looking at that map, even a dynamically generated version of that map, wouldn't tell us we were having a problem anywhere or where it was. Looking at AppD, you can get in here, and we can see that at this point, I don't know what that was, but we were having a problem there. We can go in and look at this map and say, hey, we're having a problem here. Here's the downstream effects that this is going to have. How critical is it that we need to fix it right away? How many of you guys have systems where there's something not really going right, but is it really worth putting 8 resources in a room for 2 weeks to try and fix it? Or can you just kind of let it go for a little while and figure out, down the line how to get it fixed? AppD will let you get in there fairly easily and see those impacts. See whether a batch process running slow, nobody's going to notice. But if your login transaction to your online bank takes 12 seconds, I don't know about you, but I'm going to get up and do something else. And I'm probably going to forget to pay my bill. So that's a presentation. Any questions from anybody? That is actually our whole application at one point.
And how long did it take you to use it?
To this map?
Yeah. How long did it take you to configure it so that you got it built that way?
45 minutes.
How's that? I mean, don't you have to install agents everywhere?
We actually wrote a PowerShell script that goes out and installs all the agents on all of our systems. So it was, once we had the controller up, it took about half an hour to deploy the agents everywhere. And then that level of data, at least, was visible within minutes of the agents being deployed everywhere.
How many filters do you have apply on top of that to help you with the noise?
I don't remember for this screenshot right off the top of my head. We actually do most of our active monitoring through dashboards. Typically, if we're getting into the application flow map, it's more to go look at what we think a problem is. So usually in that case, we're not going to filter it. Just because if you filter it, if you're really looking for a problem, if you filter it, you're only looking at the places you think the problem is, which kind of gets back to the legacy systems. If we think we know where the problem is, then somebody probably thought to put a log there. This gives you the ability to look at those places where you don't think you need to look that may be causing you problems.
How are you defining your business transactions?
Expand on that a little bit.
Are you having it identify them automatically, or do you have to pick choose? Because I see a number of tiers here.
Yeah.
And there's a limit of like 200.
So initially, we had it auto find all of them, just kind of in our, hey, let's get this out there and figure out how to kind of use it. Rush, I guess. We've gone in and pretty much all of our business transactions at this point are manually defined. We've kind of worked with our product owners and stuff to try and get visibility into what things really matter to them. From a product standpoint, you know, we have to kind of understand what their requirements are, what things they actually want to look at. So the auto configure works really well for giving you an overview, for getting you started, but to really get to the point that you can go to your support organizations and that kind of thing, it really takes a good bit of interaction with them to find out what matters to their groups.
Hunter, in the general session, they spoke about mean time to repair. What has AppD done for your part of the organization from this is what our mean time to repair was with our legacy systems, and now that we've introduced AppD to our support organization, this is what the mean time to repair is. Because we all know that mean time to repair is revenue for any company.
Yeah, so I don't have the exact numbers on that off the top of my head. I know one of the things that I track for my group is how many of our incidents we proactively warn our customer support group about. Prior to installing AppD, we proactively warn support about an event an average of every 9 months. We have probably 2 or 3 events a week. So we were catching a 40th, something like that, and proactively telling support about roughly a 40th of the events before they called us and said, what's going on? At this point, we're about 50-50.
But you think in your gut feel, this particular tool has reduced the amount of time it takes for your team to triage?
I actually pulled numbers on that, and I think it was about a 35% decrease in MTTR after the event was identified. The biggest gain that we had is getting the event identified way sooner. So the impact, while we had a 35% decrease in MTTR from when we started troubleshooting, from a customer perspective, that's probably closer to a 50 or 60% decrease. But I was mostly tracking it from a how much time are we spending involved in fixing the problem standpoint. Yeah, for sure.
So you were showing the call stack as far as the issue with the program, the application was concerned, the code.
Yeah.
So I mean, I've looked at some of our applications.
Mm-hmm.
I mean, and there's a lot of errors happening per minute, like 200 errors per minute.
Yep.
So then when I look at the call stack, it just says thread being aborted or something, but those are all native Microsoft calls. It doesn't show at what line of my code I made a call.
So to get the line level detail, you actually have to deploy your code, at least for .NET, with the symbol files. The symbol files from your build. Within .NET, you can have, I don't know what you use for your build system. Within TFS, I know you can have it build with the symbol files, which basically have the detail as to what's going on at the different levels or different lines of the code. It basically gives AppD visibility into the precompiled code. As is, AppD doesn't really know what the precompiled code was because all you're giving it is just the compiled stuff. So if you deploy with those symbol files, it gives it a pretty significantly deeper visibility into what the code that your developers are actually looking at is.
And it's okay to do that in production.
That depends on your configuration. Depending on how you have your system configured, deploying the symbol files can make it so that an error thrown on your website would actually have that line level detail in it. If you have good error handling in your app, then you can kind of avoid that kind of thing. We're actually working on writing an I rule for our F5s that will basically look for any time that we think that we might be exposing too much information, and we'll just give kind of a generic error page.
You just deploy the P2Vs side by side?
Yep.
Do they support a symbol server? Do you know?
I do not know.
Do you have to do any,
Go ahead.
do you have to do any configuration with deploying the symbol files, or it's automatically just picks it up?
I believe that it automatically picks it up. I'm not smart enough to know for sure, though.
And like you said, if they support it, it's just going to be automatic.
Yeah. All right, any other questions? All right, well, I'll probably hang out here for a few minutes. If anybody has any other questions, just let me know.